Hello friends, welcome to ESE online platform. As you know, ESE Engineering Academy, ESE offline, ESE online programs are meant for excellent training for all competitive examinations in the technical fields, almost in all branches of engineering. As we discussed in yesterday's class, we have seen strategy, preparation strategy for engineering hydrology. Today, as a part of the continuation of the yesterday's session, we discuss some important questions in the subject of engineering hydrology for both GATE and ESE examinations. I told you yesterday about 4 points you must be taking care of. First point is, don't make underestimate of yourself. Don't be overconfident. Don't underestimate of yourself. Don't think that all others are doing well, you cannot do anything. That inferiority complex in you will make you to go to the lower levels. Your overconfidence at the same time will lead to the greater depths of all. You be as you are. Understand your strengths, understand your weaknesses, where in what subjects of civil engineering you are strong. Give more priority for those so that you can get 100% in those subjects. If you are somewhat moderately strong in some subjects, out of 15 subjects I am telling you, if 4 or 5 subjects you are moderately strong, give 40 to 50% weightage of time allotment, energy allotment, and the preparation strategy also you can do like that. If some subjects you are having fear right from your BTech first year, now don't try to, within this 3 months time, this is already October 15th crossed, November 15th, December 15th, January 15th, almost 100-day program. Don't touch new subjects. I mean, the new subject means the subject which you are having some fear about that subject. Second point I told you yesterday, first point is, don't underestimate yourself, don't have the overconfidence on you. Second point, don't forget to be thorough with all PYQ questions. All PYQ questions, and don't forget to write mock tests as many as you can. Mock tests not only of ESE Engineering Academy, ESE Online, any institute on the globe, if they are conducting mock test, try to attend, try to register and then write. Our thinking set, mindset, the paper setters of those institute mindset, you will be coming across the various types of problems so that you will be exploring more and more new arenas so that your success level will definitely get enhanced. Don't underestimate any question. There is no good question, there is no bad question. If the question is given in the paper, it is a good question. If you are able to answer, it is the best question. If the question is given in the paper, it is a good question. If your question you are able to get it done successfully, that is the best question, because if you are able to get the success, then you will love that result. If you are not able to get the success, if you get love letter, sorry dear, I can't get you success in this year, try your best of luck next year. IIT team will send a love letter to you. Then you will get somewhat hatred towards the GATE examination for first 1 month. That's why I am warning you, my dear friends. You be what you are. Understand your strength. Understand your weakness. Try to overcome the weakness. Don't give a pose as if you are having super strength or a super boy or a super student. No person is a super student on the earth. No teacher is 100% efficient. No student is 100% perfect student. The third point, don't leave any source that is available to you. You are going on the road, let us say there is a mirchi shop, some person is eating some mirchi or some jalebi, something like that. Let him eat that, he will leave the paper, see any question on engineering hydrology on that paper is there or not. RCC question is there or not, steel structures question is there or not. Don't bother about the source. If you are able to get a new question, new model, try to attack it before you write the gate examination. Before you write the gate examination. Always mock tests are necessary for any competitive examination. I am telling you, mock tests are necessary for any competitive examination. Mock test is not necessary for marriage. Please remember this. Mock test, you write gate, you write ESE. You have to undergo minimum 20-25 mock tests, then only you will get success. Then only you will feel much familiar when you see the question on the screen in the second week of February 2024. It's the wedding day for most of the gate aspirants. Wedding day, Kalyanam. Whether you get success for the next 40 years of career or not will be decided on that day. Please don't forget this. I repeat once again. Try to have the idea about your strength and weakness. Try to overcome the weakness. Try to be balanced with your strength. Solve as many PVQs as possible. Write minimum 30 to 40 mock tests. Then number 3 is don't leave any resource. Utilize all the resources possible to get the best success. With these few points, we will see what are the important concepts of engineering hydrology, and I already have given to you what chapters you have to give with 80% weightage, 60% weightage, 40% weightage, 20% weightage, like that. Now we will discuss one by one. Please see. In precipitation, most important area they will ask is on dat curve. Given the hydrograph, calculate average intensity of rainfall. Average intensity of rainfall to be calculated. Average intensity of rainfall. The third important model we are having is data of arithmetic mean is given. Data of standard deviation is given. Acceptable error is given. How many optimum number of rain gauge stations? How many optimum number of rain gauge stations to be installed in the catchment? You have to calculate. There is also one important model. Please remember the third one. Fourth one in the first chapter is if you have a catchment area, at 3 stations we got normal average rainfalls N1, N2, N3. 2 stations are having AARF values. Normalized annual rainfall is available at all 3 stations. AARF is available at 2 stations. What is the missing rainfall data? That is also one important model. I feel in the first chapter only these 4 are the important models. In the dat curve we know pretty well. If you are able to get the curve, this is P0, this is area, this is the duration. The first model I am telling you. For a given area, it is 1 day rainfall, 2 day rainfall, 3 day rainfall, like this. For a given area, compare it to 1 day, 2 day rainfall will give the greater depth of maximum precipitation. For a given area, if area remains constant, as duration increases, P0 value will increase. Next, for the given duration of the rainfall, with increasing area, maximum depth of precipitation goes on decreasing. These 2 concepts are very important. I will just see. If area remains constant, as the duration of the rainfall increases, P naught value will increase. That is the first concept. For the given duration of the rainfall, as area increases, area of the catchment increases, P naught value goes on decreasing. These two topics are important under DAD curve, that is depth area duration curve. Second method is hydrograph, how to calculate average intensity. If you are given a hydrograph, intensity versus time, if you are asked to calculate average intensity of rainfall, total depth of rainfall by total time, how do you get the total depth? Area of the hydrograph, sigma IITI divided by sigma Ti. Calculate the areas of the rectangles. 3 mm per hour for 2 hours, 6 mm per hour for 3 hours, like that I1, T1, I2, T2, I3, T3, I4, T4 by total duration of the rainfall. Total depth of rainfall by total duration will give average intensity of rainfall. This is the symbol for, some people write I bar, some people write like this. Both stand for average intensity of rainfall. Average intensity of rainfall. Please observe this. It is also one important model. If you are asked to calculate the average intensity, calculate the area of the hydrograph. Because all are rectangles, just like a bar diagram, sigma IITI by sigma Ti will give the average intensity. The third model is a very standard model. We have solved more number of questions on this also. Once we are able to calculate, third model I am explaining here. If you are able to get the arithmetic mean and standard deviation, calculate CV 100 times sigma divided by P bar. 100 times sigma by P bar will give CV. Then epsilon is known. N is equal CV by epsilon whole square is the formula. So epsilon is the permissible error in measuring the rainfall data. IS code is permitting up to 10% error. So if nothing is given, you can take 10%. Sometimes we will say as per IS code, to calculate coefficient of variation, 100 times sigma by P bar is the formula we get, and we can get the optimum number of rain gauge stations. Already established N stations. N is already established stations. Then extra stations is given by N minus N. We can get the formula very easily. The fourth model we are having, you can see the fourth model. If you observe the fourth model, that is missing rainfall data. In missing rainfall data, you must observe the condition. If all the N values of operative stations fall within the 10% of N value of inoperative station, N values of all N values of operative stations fall within the 10% margin of N value of inoperative station, then you can go for arithmetic mean method. If at least one falls outside, then we can go for normal ratio method. Normal ratio method is the commonly used. Normal ratio method is more commonly given in the gate examination. We know the formula. Normal ratio of inoperative station is equal to 1 by, if N minus 1 number of operative rain gauge stations are there, P1 by N1, P2 by N2, so on, we can write up to N minus 1 number of stations. There are total N number of stations. Out of that, 1 is inoperative, remaining N minus 1 are operative. According to the normal ratio method, normal ratio of inoperative station is arithmetic mean of normal ratios of all operative stations. All the P and N values of operative stations are available. N value of inoperative station is available. In that missing time, the missing rainfall data can be approximately interpreted mathematically, you can get this procedure very easily. We can solve this problem. These 4 models are important in the first chapter. Let us go to the second chapter, my dear friends. In the second chapter, calculation of P bar. Simplest method is arithmetic mean method. Simplest method is arithmetic mean method. P bar is equal sigma pi by n. Second, somewhat more accurate method is Theisian polygon method. Theisian polygon method. Theisian polygon method also more accurate because weightages are given for area wise. Therefore, P bar is equal sigma pi ai divided by sigma ai, or otherwise sigma pi xi. x1, x2, x3, so on are the weightage factors. Please recall, x1 is a1 by a, x2 is the weightage factor of the second station, a2 by a, third station a3 by a, so on. Don't forget, sum of the Theisian factors is always 1. That's why nothing is coming here in the denominator. By 1 it is supposed to come. Compared to arithmetic mean method, there no weightage is given. Here weightage is given to independent areas. Every rain gauge station is allotted with some area. That's why it is more accurate compared to arithmetic mean method. If each and every point is given importance, that is isohydral method. The third method we are having is isohydral method. Third method, a question may be asked, which is of highest accuracy? Answer, isohydral method. The reason may be asked, no importance is given to any of the station. Area wise importance is given, point wise importance is given. At each and every point of the catchment, what is the rainfall recorded? That is taken into consideration. That's why most accurate method, P bar is equal to P0 plus P1 by 2 multiply with A1, P1 plus P2 by 2, average of the isohydral values multiply with included area, so on, divided by area of the catchment. When you are able to draw the number of isoheights, measure the areas between the isoheights by means of any device like planimeter. You can get the areas between the isoheights, A1, A2, A3, so on. You can get the P bar value, the most accurate method. No importance, area wise importance, point wise importance. Least accurate, moderately accurate, highest accurate. Isohydral method is also important for in the GATE examination as well as in the ESE examination. In the third chapter, we come across frequency distribution of rainfall. In the frequency distribution of rainfall, first we should calculate what is the return period. Even though there are 3 formulas available, we adopt only Weibel's formula to calculate the return period. Write down all the rainfalls given in the descending order from highest value to least value. Assign the ranks, rank 1 to rank n. Whatever rainfall is asked, whose return period is to be calculated. Identify what is the rank, its rank is m. Then time of reoccurrence of the rainfall, equaling or exceeding. If we say a return period of 80 centimeter rainfall means minimum time taken for the repetition of rainfall of 80 centimeter and above. If it is 2 years, in the coming 2 years, that much and more than that much likely to be repeated. That's the meaning of the return period. Once you get return period, calculate the probability of exceedance, calculate the probability of non-exceedance. In simple words, we say probability of success of getting a rainfall. Getting a rainfall means equal and exceeding rainfall. Probability of not getting that rainfall, ek bar P and Q aa gaya. If you want exactly R successes, NCR P power R Q power n minus R. If you want more than R successes, NCR P power R Q power n minus R. R value starts from R plus 1 to n. At least R number of successes, sigma NCR P power R Q power n minus R. R value starts from R to n. In the coming n years, your expectation should not happen even once, q power n, at least once, 1 minus q power n. Most importantly, most commonly, they will ask the questions on probability of getting the rainfall at least once in the coming 10 years, at least once in the coming 6 years. Not even once, q power 1, at least q power n, at least once, it's complementary. Complementary of q power n is 1 minus q power n. These 6 formulas, please don't forget. Don't forget Weibul's formula to calculate the return period. एक बार return period आ गया तो probability of success, probability of failure, then first one, how to get R, exactly R successes in the coming n years. At least R successes, third formula. More than R success, second formula. Not even one success in the coming n years, fourth formula. At least once in the coming n years, fifth formula. If you remember these 5 formulas, formulas of P and Q. P and Q depend on T, T depends on n plus 1 by m. So you are able to get any of the problems solvable by these 6 formulas. Very important chapter, third chapter I told you. If the questions on precipitation and average depth of rainfall is not given, guess, you take it granted, one question comes from frequency distribution. Out of 1 to 3 chapters allotted for precipitation, one question is must. If not on that car, he will give on frequency distribution or the Thesian polygon method or isohytal method. He may give as the following question also. So this is the summary of the third chapter formulas, and let us go to the fourth chapter. First I am giving, before giving some examples, first what numerical concepts are needed, what important questions are likely to come. I am trying to give a gist so that you can have overall idea in the preparation procedure. Fourth chapter is evaporation. What subtopics are there already I discussed. Rate of evaporation is equal to C into A plus BV into PS minus PA is the formula. This is called Dalton's law of evaporation. All the 10 factors influencing the rate of evaporation is important to calculate by evapometer on the bank of a river or reservoir. Evapometer, if we want to calculate the rate of evaporation, E on the water body is equal to Cp multiply with E on the pan. Cp multiply with E pan is given by P minus Z. Z is equal to volume of water added or removed divided by surface area of the pan. Generally only Indian and American pans are given. For American pan 0.7, for Indian Standard Weather Bureau Class A pan, you will get Cp value 0.8. This formula is important for us evapometer. Second method is Mayer's equation. Mayer's equation only E is given by, that is the only one important formula, C into 1 plus V 9 by 16 multiply with PS minus PA. V9 to calculate V1 by V2 is equal to Z1 by Z2 to the power of 1 by 7. 1/7 power law is valid. You can measure the speed of the wind at the free surface of the water in the reservoir. You can calculate at 9 meters height with the help of this formula. That is V9 we are going to get very easily. This is called Mayer's equation. The third formula in evaporation is mass budget method. It is based on the principle of conservation of mass. Sum of the inflows I plus A into P minus sum of the outflows O plus AE plus SE is equal to A into S2 minus S1 by delta T. This is principle of conservation of mass. I is the inflow, A is the surface area of the water body, P is the rainfall in the time of delta T, outflow from the catchment, E, rate of evaporation, SE, seepage loss, S1, S2, initial water levels in the water body. The change from S1 to S2 has happened within a time of delta T. This is sigma I minus sigma O is equal ds by dt is the formula. Most important formula is called conservation of mass principle. It is called principle of mass budget. The next one is conservation of energy is called energy balance method. From that we are going to get the formula E is equal Q solar divided by density of water multiplied with latent heat of vaporization. With appropriate conversions into SI system, if you take everything in SI system, you will get E value in meters per second. From that you can convert into millimeter per day, the general unit we are going to use for rate of evaporation. Transpiration is not that much important for numerical problems. Theory questions may be asked, why sunshine is only during sunshine transpiration is prominent like that. What is the device we use to measure the rate of transpiration? Phytometer. Like that questions may be asked, but numericals are mostly from few. If it is given in the 4th chapter, they will give from the evaporation chapter, or chances are there in evapotranspiration. In evapotranspiration, if you look at the evapotranspiration, my dear friends, calculation of PET, two formulas are important. Penman's equation is not generally used. One is Basal's equation. PET is equal K into E. Second one is Blaney-Cradle equation. PET is equal K into P into Tm divided by 100. K in both the equations, K is equal plant factor into soil factor. Here and here, K is the product of plant factor and soil factor. Here E is the evaporation, P is the percentage of sunshine hours, Tm is average monthly temperature in degrees Fahrenheit. Degrees Fahrenheit. Temperature conversion factors, you must remember this value you will get inches per month. From inches per month you can convert into centimeter per day, centimeter, millimeter per day, like that you can convert. Friends, if the question is given in potential evapotranspiration, they will ask either in Basal's equation or Blaney-Cradle equation. Compared to evaporation and evapotranspiration, more chances are there to get a question on evaporation chapter. Try to solve as many numericals as you can from various resources that are available, including internet, including PYQ gate and ESE. In the 5th chapter, let us see what are the important questions. The 5th chapter is infiltration. Even though there are 4 methods available, field method is called single ring infiltrometer, double ring infiltrometer, and laboratory method is rainfall simulator. The 3rd method is important, that is Horton's ICC curve. Horton's ICC curve, chances of questions are given. Between 1st hour and 3rd hour, what is the depth of infiltration? You can calculate the area. I know this equation, Ft is equal to Fc plus F0 minus Fc into e power minus kT. If you integrate that, I want the depth of infiltration between T1 to T2. Depth of infiltration, the time interval is equal to integral Ft dt. Ft is the equation. Ft because it is F0. Constant value is Fc, we know pretty well. I am not giving all the fundamentals from time T1 to T2. During 3rd hour, 2nd to 3rd. 6 hours rainfall, last 2 hours, 4 to 6. Very, very easy to apply Horton's infiltration curve. Infiltration capacity curve is one area where the question is commonly asked. And total depth of infiltration for pretty long time of rainfall is also given by Fc into T plus F0 minus Fc by K. It is also one important formula. Most of the problems you can solve within 1.5 minutes by applying this formula without going for integration. You will get somewhat easier way. T is the time duration of rainfall. Fc is the steady state minimum rate of infiltration capacity. F0 at the start of rainfall, initial intensity of infiltration. K Hartness constant. You can get the total depth of infiltration. That is the third method. Fourth method is calculation of W index. Don't forget the formula. P minus R minus delta E divided by total rainfall duration. Only during the runoff existence time, effective rainfall duration, that's called phi index, is equal to P minus R divided by T. You know pretty well W index is a more valid, more reliable, more authentic compared to phi index. W index is called average rate of infiltration. Phi index is called effective rate of infiltration. In effective rate of infiltration, initial losses are also taken into the runoff factor. Here separately taken, runoff is different, initial losses like interception and depression storage are different. That's why W index is more reliable, more authentic value, we can say, to give the nature of the catchment area regarding the process of infiltration. And from this we can calculate DRO depth, we call direct runoff depth. From the infiltration indices we can calculate. This is given by P minus W into TR minus delta E, or one more formula, PE minus phi into TE. Any one of these formulas we can use in infiltration. 6th chapter, runoff is not that much important. 7th chapter, catchment characteristics. In that, only compactness coefficient is one important formula in the catchment characteristics. As the time is limited, I am just giving the overall glimpse. Catchment CC is equal to area of the perimeter of the catchment divided by square root of 4 pi into area of the catchment. If you know the catchment parameters, one is the perimeter, one is the area. CC value, P divided by root of 4 pi A. One more formula, form factor. Form factor is equal to area divided by square of the length of the axis of the catchment. Square of the length of the axis of the catchment. CC and FF are important in the catchment characteristics. When you come for hydrographs chapter, be thorough with A to Z. How do you calculate DRO depth? Area of the direct runoff hydrograph divided by area of the catchment. How do you get area of the DRH? Number of 6 methods are available. You must be thorough with all the methods available. How to separate the base flow? What are the measures available to separate the base flow? Such methods are important. How do you get from 2 hour to? How do you get from 2 hour to 4 hour, 6 hour, 8 hour, like that? You have to apply principle of superposition. Principle of superposition, if you are increasing by n number of times, if D is becoming ND, lagging is done n minus 1 number of times. We know this procedure. D must be changed to D hour unit hydrograph is changed to ND hour unit hydrograph. Then principle of superposition, if you are using S curve from 2 hour, either 1 hour or 3 hour or 4 hour, anyone you want, I can go for S curve hydrograph. S curve hydrograph. So first S curve SA lagged by T hours from D hour UH to, you want to construct a T hour UH. T hour UH, from here lagged by T hours you are going to get this. It is SA, it is SB. Then T hour unit hydrograph is given by SA minus SB divided by T by D. You are able to get very easily the formula for ordinates of T hour unit hydrograph. Formulas of Cinder's unit hydrograph is also important. Time of concentration is one important area. Time lag is one important area. Qmax is one important area in Cinder's approach. Please try to practice the Cinder's 5-6 formulas. They are also important. And then in these particular hydrographs, concepts of unit hydrograph, assumptions of unit hydrograph, drawbacks of or limitations of unit hydrograph, area of the catchment should be between 20 kilometers square to 5,000 kilometers square. Rainfall should be uniformly distributed throughout the area. Rainfall should be uniformly distributed throughout the duration of the rainfall. It must be a single rainfall, single peaked rainfall. Time invariance, it's not important when the rainfall occurs, it's important how long the rainfall occurs. Sometimes they will give the problem B2 minus B1 is equal D2 minus D1. Change in the duration of the base period is equal change in the duration of the rainfall. This is also one important relation we come across in the hydrographs chapter. As I told you, first importance hydrographs, second importance precipitation, third importance well hydraulics, fourth all other chapters. All other chapters. First one is hydrographs, second one is precipitation, third one is well hydraulics, the groundwater hydrology. Remaining all chapters you can have a glance. Then in maximum flood estimation, try to follow the empirical formulas. That is, Ravi's formula is important, Dickens' formula is important. Simple formulas on Gumbel's extreme value distribution is also important. Gumbel's extreme value distribution. Don't forget to calculate YT. From that you will get KT. From that you will get XT. XT is equal to X bar plus KT into sigma. So this is regarding maximum flood estimation important. Flood routing, nothing is important except the Muskingum method. So ON is equal to C0IN plus C1IN minus 1 plus C0IN plus C1IN minus 1 C2ON minus 1. Present outflow depends on present inflow, previous outflow. C0, C1, C2 are called Muskingum coefficients. Those formulas are important. What is a linear water resources system, non-linear water resources system? If storage is a function of only outflow, no inflow influence is there, linear system. If storage is a function of both inflow and outflow, then it is a non-linear system. Here C0 is equal to C1. We can understand this in the flood routing chapter. Next chapter is the most important chapter, is the well hydraulics. In that, first formula, porosity is equal to specific yield plus specific retention. Second formula, change in the groundwater storage is equal to SY into area into change in the groundwater table. When you have some change in the groundwater table, it will lead to how much change in the water storage, groundwater storage. This is important. K is equal to K0 into gamma water by mu. Relation between permeability and intrinsic permeability. Then V is equal to Ki Darcy's law. Q is equal to Kia. Then absolute velocity is equal to V divided by N. Porous velocity divided by porosity will give you absolute velocity. Then formula for discharge through unconfined aquifer. Formula for discharge from a confined aquifer. Then time of recuperation, T is equal to 1 by C log H2 by H1 by H2 to the base E, or C is equal to 1 by T. These formulas are important in the well hydraulics. Flood routing, if they ask, they will ask only on measurement of discharge by tracer method. That is also one important one. Calculation of Q by is also called dilution method or otherwise tracer method. Discharge in the river or stream flow is equal Q0 multiply with, Qt multiply with Ct minus C0 divided by Cm minus Ct. This is the formula we get. Ct minus C0 by Cm minus Ct. I think it's not correct. So Q for the discharge Q change is Cm minus C0. For a discharge Qt change is Ct minus Cm. So the formula for Q is equal Qt into Ct minus Cm divided by Cm minus C0. This is the correct formula. So if C0 is negligible and Ct is very large compared to Cm, simplified formula Q is equal Qt into Ct divided by Cm. By tracer method, concentration of the tracer element at the moment of adding, concentration of the stream, water in the stream, concentration of the tracer element in the mixer after half kilometer minimum thorough mixing. This formula is also important. Other formulas, where do you calculate the average velocity? V at 0.2y, V at 0.8y by 2. If it is a 2-point method, 3-point method, 6-point method, a single point method, V is equal to V at 0.6y. So those formulas are standard formulas, very important formulas. The summary of the formulas we can have, and let us see some more questions to have a review. Match list 1 with list 2. Select the correct answer using the codes below. Phi index will give effective rate of infiltration, so A4. Lysimeter is used for the measurement of rate of evapotranspiration, B3. A4B3. A4B3 is only one option. Without any doubt, without wasting your time, A4B3. Phi index is for effective rate of infiltration. Lysimeter is for rate of evapotranspiration. W index is for the measurement of average rate of infiltration. Phytometer for the rate of transpiration. A4, B3, C2, D1. So C is the right option, my dear friends. Falling limb of a hydrograph is a function of so many examinations. It is asked. Rising limb depends on rainfall intensity, rainfall characteristics. Falling limb depends on catchment characteristics. Catchment characteristics means storage characteristics. Which of the following zones of a soil profile relate to the zone of aeration? Zone of aeration. In what zones of soil? As you know pretty well, if it is the ground level, first one is the root zone depth, we got air. Second one is the capillary fringe, so intermediate fringe. Third one is the capillary fringe. In the first three parts we are having air. In all the three cases, soil plus water plus air is there. Here it is saturated groundwater storage. It is the saturated one, soil plus water. In the first three, soil plus water plus air is there. Capillary zone, intermediate zone, soil water zone. So BCD is a multiple selection question. BCD is the correct answer for this question. 6-hour unit hydrograph of a catchment is triangular in shape with a base width of 64 hours, peak coordinate of 20 meter cube per second. If a 0.5 centimeter rainfall excess occurs in 6 hours in that catchment, the resulting surface runoff hydrograph will have dash. This is 6 hour 0.5 centimeter rainfall in occurs in 6 hours in that catchment. Then 6-hour unit hydrograph of a catchment. 6-hour unit hydrograph of a catchment has 64 hours of base period and 20 meter cube per second. This is 20. If a 0.5 centimeter rainfall excess, R value 0.5 centimeter in 6 hours in that catchment, the resulting surface runoff hydrograph will be dash. So this is peak value 0.5 centimeter. It is 1 centimeter for 20, 0.5 centimeter will have peak value 10 meter cube per second. Base period remains same 64 hours, but as intensity of rainfall decreases, your peak value gets decreased. So peak of 10 meter cube per second is the right answer for the question. An area is classified as a drought prone area if the probability of occurrence of drought is 0.4 to 0.6, very rarely 0.2 to 0.4. So A is more correct answer for this. An area is classified as a drought prone area. When a plot is drawn between stream discharge against percentage of times the flow is equal or exceeded, that is called flow duration curve. Flow duration curve, discharge on y-axis, percentage times the flow is exceeded or the flow is equal or exceeded. That is 100 into P. 100 times the probability of exceedance, we will be getting the graph like this. This is called flow duration curve. Mass inflow curve is accumulated rainfall versus time. Double mass curve is accumulated rainfall of the doubtful station about the consistency versus average of the accumulated rainfalls of the remaining n-1 number of stations. SCN curve is soil conservation number curve. It all depends on the soil conservation agency formulas. ABC are not correct. D is the correct answer, flow duration curve. A 25 grams per liter solution of a tracer was discharged into a stream at a constant rate of 10 centimeter cube per second. Background concentration of the dye in the stream water is 0. So C0 is 0. CT will be 25 gram per liter, 25,000 milligram per liter, that is 25,000 ppm. Milligram per liter is, we know, ppm. At a downstream site sufficiently far away, the dye was found to reach an equilibrium concentration of 5 parts per billion. Cm will be 5 ppb, 5 into 10 power minus 3 ppm. As you can see, CT is much larger than Cm. Cm is larger than C0. So I can use the simple formula. Q in the river is equal Qt into Ct divided by Cm. What is Qt? 10 centimeter cube per second. 10 into 10 power minus 6 centimeter cube to meter. Answer is given mostly in meter cube per second. 10 into 10 power minus 6 centimeter cube to meter cube is 10 power minus 6. Ct value 25,000. Cm value 5 into 10 power minus 3. 10 power minus 6,000, 10 power minus 3 gets cancelled. 250 by 50, you will get 50 cubic is the answer. See, where is the 50 cubic? D option is correct option. I told you, dilution technique is very important technique to measure the discharge, especially in the industrial waters and natural rivers. This formula is also very important formula. You can see, don't forget the 5 parts per billion. 1 by 1000 of ppm is called ppb. If F is the area of the catchment, P is the perimeter, what is the formula for compactness of the coefficient? P divided by root of, this is A, sorry, printing mistake, P by Cc is given by perimeter by root of 4 pi A is the correct answer for the problem. For a circular catchment, Cc value is 1. Whichever catchment area whose Cc value is much closer to 1, that is the better catchment. If one catchment is having Cc value 0.99, second value is 1.02, 0.99 is closer to 1, therefore first catchment is the better catchment. More closer to 1, more closer to fan shape. Fan shaped catchment is best, fan shaped catchment is the worst. I told you in one of the previous sessions. It is observed that by increasing the catchment area by 1500%, peak discharge is increased by 700%. The catchment might be located at from the peak flood area empirical relationships. Is also a good question. Area is increased by 1500%. Peak discharge is increased by 700%. So if A1 is 100, A2 increased by 1500, so it becomes 1600. If Q1 is 100, Q2 will be 700 increment becomes 800. I don't know where the catchment area is available. South Indian catchment, example Tanjavur. Central Indian catchment, example Nasik. American catchments, Washington DC. North Indian catchments, Haridwar. So you have to see in what, whether it's a North India or South India or Central India or America, we should know from this data. For any catchment area, general formula Q is equal C into A power N. So Q is proportional to A power N. Q1 by Q2 is equal A1 by A2 to the power of N because E is a constant. Q1 is 100, Q2 is 800, A1 is 100, A2 is 1600 to the power of N. Hundreds, happy. It is 2 cube, 1 gets cancelled. 2 cube is equal 2 power 4 N, base cancels, N value becomes 3 by 4. If N value becomes 3 by 4, Q is equal C into A power 3 by 4. Recall, Q is equal C A power 2 by 3, Ravi's formula. Q is equal C A power 3 by 4, Dickens formula for North Indian catchment. It is North Indian catchment. Answer is Haridwar is the right answer. Haridwar, unless otherwise we know the exponent, you cannot decide in what catchment area, that in what area of India we can have that catchment area. Because N value we got 3 by 4, so Q is equal C A power 3 by 4, Dickens formula, which is applicable to North Indian catchments. अगर आपको 2 by 3 आ गया तो South Indian catchments answer Tanjavur. 1 by 2 आ गया तो English formula Central Indian catchments. 5 by 6 आ गया तो American catchments Fanning's formula. So अगर कोई ना कोई problem maximum flood assessment में दिया तो देना चाहते तो they will give either in the Gumbel's extreme value distribution or otherwise a problem like this. It is also one important model on engineering hydrology applicable for both GATE and ESE. A catchment has 6 rain gauge stations. 2 of them are recording type. Average depth of rainfall 90 centimeter. Standard deviation 22.5 centimeter. IS code provision for permissible error. Additional number of recording type rain gauges are dash. First of all, calculate N. What is CV? 100 sigma divided by P bar. 100 into 22.5 divided by 90. This will give 4 times. 4 will give 25. So CV will be 25%. IS permissible error epsilon is 10%. N is equal to CV by epsilon whole square. 2.5 whole square, that is 6.25. अगर आपको N value 6.25 आ गया, so minimum number of stations are 7. Already established how many? 6. Out of 7, recording type rain gauges are minimum 10%. minimum 10% must be, minimum 10% must be of, minimum 10% must be of recording type, of recording type. So 7 may 10% is 7 may 10% is 0.7, that is 1. 10% of 7 means is 0.7, next higher value 1. Only one recording rain gauge is sufficient. Recording type rain gauge is sufficient. But already how many are there? 2 of them are recording type. Only 1 is sufficient. Already you got 2, therefore answer is 0. Additional number of recording type rain gauges, 0. If I are asked additional number of rain gauges, already 6 are there, 7 are to be established, if your answer is 1. What are the total number of rain gauge stations that must exist in the catchment? Answer 7. So like that you can answer. And this is also one important one. Based on mass transfer equation and energy budget equation, which of the following equations are more? Once you say mass transfer, thermodynamic property, variation of saturation vapor pressure with absolute temperature, Penman's equation. Penman's equation is the right answer. A catchment has 150 hectares, runoff to rainfall ratio 0.4, runoff to rainfall ratio K value 0.4, area 150 hectares. Due to 10 centimeter rainfall, over the catchment, a stream flow at the outlet of the catchment lasts for 10 hours. Average stream flow in that period is dash. Q is equal to KIA. K is 0.4, I 10 centimeter, 10 into 10 power minus 2. Rainfall, outlet lasts for 10 centimeter intensity of rainfall. You should give the rainfall to duration of the catchment lasts for stream flow at the average stream flow in that period is dash. KIA formula. Here time of concentration is given 10. It's not that much data is missing. Area is 150 hectares. 150 into 10 power 4. 10 gets cancelled. This is 60. 60 into 100, 6,000. 6,000. 150 into 0.4, 60 into 60 into 100, 6,000. 6,000 meter cube per second by 60, 100 meter cube per minute. This is the correct answer. 100 meter cube per second. 100 meter cube per second. 100 by 60, nothing is there. Per hour, 6,000 into 60, 36, no. So only B is the correct answer for this question. Please understand. Observe the following statements. A 100-year flood discharge is greater than 50-year flood discharge. Definitely correct. 90% dependable flow is greater than a 50% dependable flow. Yes. Evaporation from salt water surface is less than that from fresh water surface. True. All three are correct. So D is the right option for the given question. D. All three statements are correct. Given a D hour unit hydrograph, D2 hour unit hydrograph for the catchment can be developed. The method of superposition is applicable. Reason is not always correct. So if D2 is equal to ND1, where N is integer, then only principle of superposition is valid. So A is correct, R is wrong, A is correct, R is wrong. Option C is the correct option. A and R are correct, and R is the correct explanation of A. That is A, B, C, D we know. A correct, R wrong, therefore C is the right answer. My dear friends, because of the limitation of the time, we are able to give only some important models, but in the real sense, there is no important problem, there is no unimportant problem. If the problem is given in any one of the previous papers, if the problem is given in any one of the mock tests, it is an important model. Please prepare well and don't neglect anything. Don't neglect any concept, any problem. Try to put your maximum efforts. 110 days or approximately 105 to 110 days. Ensure all your efforts will be put collectively to get the best success possible. Good luck to you. Good luck. Thank you very much for listening to me.